Hi guys, so today's job is to do 5 of these round knives for a stripping machine. It cuts cables basically for scrap. They cut the plastic and remove the copper and send the plastic and the copper for recycling. And we need to make 5 of these knives. Diameter 90 millimeters, a bore with 22 millimeters, 3 millimeters wide, and 25-degree included angle of a cutting edge. Not crazy precise, even the through hole is not crazy precise in this case, so it can be off from a hash 7 tolerance. Let's see how I will make this knife. The material I choose is D2 tool steel, or 1.2379 in Europe, or the X155 chrome vanadium molybdenum 12. How do you call this? Those are equivalent steels. Here we have a chunk of 91 millimeters. I will bandsaw off like 5 millimeters and hold it in a chuck, face, drill, finish the bore, flip and face to the final thickness. I will surface grind to the 3 millimeters. The 3 millimeters is not important in this case, but we need to be perfectly sure that they are parallel and not break while you clamp them down. So that is the important part, to be parallel, not to be the perfect 3 millimeter thickness. I will send this for heat treatment. I will heat treat them under 60 Rockwell C, because in the past, who made those knives for this company, the problem was they will chip pretty quickly. So I will do it now under 60, so we hope that the cutting edge will be softer and remain sharp and not cheap for a long time. Usually I make these types of knives over 60 HRC, 62 and 64, roughly like that, but in this case I try to stay under 60 to maintain a little bit of elasticity and not chip at the first impact with the copper. So let's bandsaw 5 pieces out and go to the lathe. And this is my bandsaw. It cuts pretty nice and pretty fast. Now it's a time-lapse video, so it shows it real quickly. But it took a couple of minutes, so I'm not just sitting and wait the machine to finish cut. I do other stuff around the shop. For example, now I built extension for my shop, so now I put this polyurethane foam around the ceiling and the walls. And this is the chuck that I use. It has a 3 millimeter step machined in the jaws, so it's perfect for this application. Now a short time lapse for making the first part, or the first couple of parts, I don't know exactly. Drill with 19.5 millimeters, roughly 1 millimeter pass, measure it with a mic and do another finishing pass. So this is how the diameter turned out. It's like plus 0.01 millimeter, so the fit is perfect. I don't leave for grinding, because with this company that I work that do heat treatment, they heat treat in the vacuum chamber, so the part basically doesn't distort. I never had a part to have distortion after this heat treat, since I work with since I collaborated with this company. So they make very nice job. They are basically specialized just in heat treatment, all kinds of heat treatment. So now machine the other face. I have flipped the part and now I machine it to length. And this is another time lapse to see how it goes. It goes pretty quickly. This is the basic turning, nothing special right here. But here is the tricky part. I want to show how I turn out the outside diameter and how I make the 25-degree included angles, how I machine them. I just pressure turn them. Using the hole, this ensures also contact to the steel tubing and also concentricity plenty enough for this part. One whole thing is just a pipe that I have holded in the chuck pretty tight and faced it and put a live center, press it. I spin it a little bit to self-center. After that I lock the quill and machine the outside diameter. One part I didn't push enough on the tailstock and slipped a little bit, but it will work just fine. I don't know exactly if this part is or another part. The diameter is roughly 90 millimeters, a little bit undersized. It is perfectly fine. I don't let too much for grinding. I will grind probably this on the lathe, just put a biax in the tool post and hand grind to be a sharp edge. I will machine the edge very sharp, and just the final touch will be after heat treatment. And now I moved the tool post slide to make that angle. Same setup, same pressure turning, so no fancy, crazy, exciting machining. Just a little bit of pressure turning, and it worked very, very nice. I'll machine the first part or the first angle and just release the pressure on the tailstock, flip the part, and machine the second angle. It's nice because I have a DRO, so all it's pretty repeatable, and it make a very, very easy work to do stuff like this. The drawing that you saw was made by me. They didn't provide any drawing for this part, just an old part that was like 85 millimeters in diameter, and said they wanted a little bit larger, so I choose 90 millimeters. So even if I mess up and ground like 1 millimeter while sharpening the knife, we are still be in tolerance, because we don't have any outside diameter tolerance for this part, just to be larger than 85 millimeters. They reground, they will reground as they were, so the outside diameter always is changing. The knife is on the slide, so they pre-tension always the knife, and that's why the outside diameter doesn't matter. Surely it is a minimum outside diameter, and after that they scrap the knife and put a new one in. And this is how they look after the lathe job. They look pretty nice. Now I send them out for heat treatment, and after that we will grind them flat and grind the angle for the cutting edge, and that's it with this job. And they are back from heat treat. They look pretty decent, have no oxidation, just the discoloration from the heat treatment. They are between 59.7 and 60 HRC. They came with this certificate. They measured them, and this is what they measured. They are basically exactly what I asked for. I will not grind them flat because I run out of time. I need to bring them back today because I have a bunch of parts to bring to this company. So I will grind them, just press a turn and grind with the biax scraper, just a little bit of the cutting edge. And that's it for this batch of parts. Bye, and thank you for watching.